So here I'm going to go ahead and talk about the fundamental theorem of algebra. And to do that, I have a couple of examples here. Now, I chose second degree polynomials, just quadratics, but this will work for any polynomial. So the fundamental theorem of algebra has to do with the zeros. So let's go ahead and look at the zeros of the equation on the left here, because they're pretty easy to find. And let's take a moment and just realize that this is a second degree polynomial, and we end up with two zeros and two factors. I wonder if that's something that is always true. Well, in fact, that is what the fundamental theorem of algebra says. It says that the degree of the polynomial is the same as the number of zeros or factors. Now, the second equation, I meant to already do this, but I'm going to just change it slightly. And we'll see why in a sec here. But if we go through that same process, we find that, oh, you know what, this totally isn't factorable. So let's go ahead and use our trusty quadratic formula. And what we end up with here is we end up with a negative under our square root. So I guess that just means that this has no zeros. But wait a second. Mr. Cooley just said that the degree of the polynomial is always exactly the same as the number of zeros. And this is a second degree polynomial. So what does that mean? Well, that means that we have imaginary zeros. So if we clean this up, we wind up with these two imaginary roots, -6 plus I times the square root of 60 over 8, and -6 minus I times the square root of 60 over 8. Well, that's cool. That fits in with our theorem here. And the important thing is to realize that if we have a non-rational zero, so either imaginary or irrational, we're going to get that plus or minus in there. Well, real quickly, let's look at what happens here if we plug it into the quadratic formula and why we don't end up with that plus or minus relationship. All right, and since we already know the answer, I'm going to go ahead and stop here, but this is what I was getting at. The reason why we don't end up with that conjugate pair, okay, remember the plus or minus is a conjugate, right? In this case, it's a complex conjugate. But here, the reason we don't end up with that conjugate pair is because the square root is that of a perfect square, 1. So the plus or minus goes away, okay, because we can actually evaluate the square root. The key to this, though, is again that big concept that no matter what, we're looking for the same number of zeros as our degree. The second thing is any non-rational zeros are going to come in conjugate pairs. And that's it. That's the fundamental theorem of algebra.